I want to add a little bit more to the idea of this ENSO monsoon interactions, but again, going back to a couple of points we made earlier. One of them was this persistence of SST anomalies across seasons and the difference between the Indian Ocean and the Pacific Ocean, for example, which obviously must relate to the ENSO monsoon interactions as well. We were looking here at 6 months persistence going from JJA to DJF, which is strong in the Pacific and also existent in the North Indian Ocean. But when we went from DJF to JJA, we went through the spring barrier, and you can see that the deep tropical Pacific has much lower persistence here, whereas the North Indian Ocean maintains its persistence, which you can see in this construct of Haumüller diagram, longitude versus seasons. Atlantic has a strong persistence from DJF to JJA, not so strong from JJA to DJF, whereas Indian Ocean pretty much has a strong persistence throughout the year, except in the far west here, okay, which is very different than the Pacific. Okay, this is often also used to relate the time scales. For example, here we have said that the El Nino has a strong quasi-quadrennial time scales, 2 to 7 year range, even including the decadal variability, multi-decadal variability. In the Indian Ocean, seasonal variability is the strongest between the monsoons, northeast, southwest monsoons. Interannual and all other time scales have much smaller variance in SST, for example. Of course, intra-seasonal timescales show up as there's some chopper buzzing around that's going to make some noise here. I hope it's not too much of a disturbance. I'll see if I need to re-record it. Okay, so taking that, the ideas of going from a quasi-quadrennial time scale here to somewhat of a quasi-biennial time scale here that we already mentioned. Ideas have been proposed by Neville Nichols, Harry Hendon, Alan Clark, and so on, that the change in persistence timescales across here create a unique change in interactions, because the winds and the SSTs have different relation based on the season. So SST anomalies can persist, but the wind anomalies change sign because of the seasonal cycle. So that creates a change in time scale. I'm kind of very briefly saying it, but you can look up the details. But this Indo-Pacific tripole then raises that question as well, that how do you go from a intrinsically different time scale here to here? Obviously some transition happens here, and that's what was proposed by Dak Chen as mostly the big gorilla in the room, Pacific forcing the Indian Ocean. But there are times like the 20s to 60s when the SOI and monsoon correlation almost disappeared, El Nino variability, El Nino variance goes down, and so on, that we looked at with wavelet spectrum. And you can see then that the Indian Ocean can begin to have a much stronger coupling to the Pacific and maybe drive the Pacific as well. There is really a huge amount of literature on that I'm not going into, but since this is not specifically mentioned in the book, I just wanted to add it. Plus, I want to also emphasize maybe the special role played by the Eastern Indian Ocean, where we had already seen that the strong cross-equatorial pressure gradient here is associated with strong vertical stability, which prevents high rainfall and inertial instabilities on the Western Indian Ocean. You can see that here in this simple pentad precipitation climatology animation, if you will, basically goes from the beginning of the year to the end of year and recycles, and you can stare it at your own leisure. But you can see in the beginning of the year, ITCZ is to the south. As sun moves north, the ITCZ wants to move north, but begins to split up. and we have the special cross-equatorial pressure gradients, subsidence and lack of rain over here. A lot of action over here. Okay, so you can see that there is this relation between Indonesian rainfall, Eastern Indian Ocean, the marine ITCZ, the northward propagating systems, and so on. And that relates to some of the nice papers by V. Krishnamurti with Jagdish Shukla, arguing that there is a seasonally persistent mode over here, and there are propagating modes. So maybe monsoon is not a monolithic thing, that it has a trough and a persistence of precipitation over the season, with the intraseasonal mesos and the monsoon depressions adding the higher frequency variability. But nonetheless, I want to emphasize that this transition of time scale in the Eastern Indian Ocean may be something to look more deeply into. That also shows up in the sea surface temperature pentads. You can see that the pre-monsoon warming is strong, and that also affects the monsoon in terms of warmer and colder anomalies. But once the monsoon season starts, you can see that the strong upwelling associated with the alongshore southwesterlies here produces weakening. So you can see here, so you have warm temperatures and ITCZ holding on here, and of course the high precipitation, convection and monsoon rainfall on this side, but the cooling and so on this side. You can also see that in terms of the annual cycle of the 850 hectopascal and 200 hectopascal winds over the northern Indian Ocean, you can see that the strong and weak monsoon years, the surface winds do not change that much if you go from the peak July rainfall to 6 months before and 6 months after. So there is not a huge difference in the surface winds. So the southwesterlies near the surface or in the boundary layer, just above the boundary layer, let's say, are pretty strong in both cases as the monsoon arrives. But it's the vertical structure of the jet that is changing quite significantly, and with a sufficient lead-lag relation, and that you can see here in terms of the 200 millibar winds, 200 hectopascal winds for strong and weak monsoons. So you can see that the upper level easterlies are much stronger, so the vertical shear would be much stronger in the case of strong monsoons compared to the weak monsoons, which should affect the energy that's available for the northward propagating monsoon interseasonal oscillations, as we will see later on, the relation between the shear and the northward propagation. There are also papers relating that to other features like vortex advection, vorticity tilting, etc., which we may not get into. But again, this signal is there many months before the July peak in monsoon rainfall. So does that imply remote forcing? Does that imply predictability? Does that imply large-scale dynamics? And so on have to be more carefully understood. But you can see that this Indo-Pacific region, without even including the Atlantic or the northern oceans, is quite a complex mix of timescales from synoptic few days to subseasonal to seasonal and interannual and longer timescales, because these are also modulated at multi-decadal timescales as we saw. Okay, so I wanted to raise that as a separate podcast and then move on to the further details of the monsoon dynamics. Okay.